Okay, yeah, okay. So it's a pleasure to introduce the first fantastic speaker that we have today, Silvano. Come here and please introduce yourself.
Actually, I might introduce myself a bit later during the talk because I have some slides about it. So, I mean, if we can start with the slides already, that would be better. Just go full screen and okay. Does this work? Okay, cool. So yeah, I'm Silvano Cerza, the guy over there. I'm a senior software engineer at DeepSet, and I work on the A-Stack framework, one of the major LLM frameworks. In in the past, I worked at other cool companies like Arduino and Peach. Actually, this 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 presentation has been made with Peach, so I've been still kind of work there. And so yeah, I'll be talking about agent, and I'll give you a small introduction on what is actually an agent, what can they do, and how one can build agents, and then I'll have some time for some questions if you want. So first thing first, what is an agent? I guess everyone is familiar here with LLMs or large language models, and you get a question in, and you get an answer back, something like that. To make an agent, I mean, that's the starting block at least. To make an agent, you need something more. The first thing that you're gonna need is reasoning. The model needs to reason about what it needs to do. So you give it a question, it thinks, and it splits into smaller solutions or answers, let's say, and gives you a final answer, let's say. Then you need another thing, lots of other things actually. You need tools. You need somehow some way for the model to do something else other than generate text, or at least generate text that can be passed to tools and then call those tools somehow and get the result back most of the times. That's also called function calling, because I mean, those are gonna be functions, and that makes your model much more powerful. It can do much more than just question answering. It can do task. It can actually do and solve a complex task and return you a result through reasoning, choosing the right tool for the task that it needs to solve, and then returning a result. If the actual task at hand or multiple tasks at hand actually are supposed to return a result, it could be also that the result is just status success, done, cool, and that's how you get an agent. And a really simplistic thing. I mean, that's the gist of it, at least. So, what can they actually do? I actually done some things in the past, created some agents. This is actually a small agent that I created for a previous talk that I hope that everyone can read this. That you can that I made basically some weeks ago for another speech, and basically this is an economy expert that has access to financial data for the Italian government for 2024, and I can actually ask, since we're in Puglia, I asked how much did the region Puglia plan to spend on startups in 2024. It generates something. It has access to queries. It returns an error, something like that. It recovers from that error and keeps going. And this is not the best example, but it actually gives you kind of some answer in the end, even if it didn't manage to actually execute the tool correctly, but it returns some error. So I nudged it a bit and say, just get the data for Puglia and use it as lowercase, because I noticed that through the tool calling, it actually called made a query with an uppercase name that it's actually not saved like that in the DB, so it didn't work. So it's still errors. I mean, that's part of it. And right now it's querying the DBs, so that's why it's taking a while. At certain point, you're gonna see a ton of data, and it's gonna use that information to give me an answer. It can also be, if I remember correctly, in this case, it's gonna tell me, look, I don't have enough information to tell you the answer. Maybe I can do this other thing, and let me speed it up a bit, maybe. Okay, that was a long query. I mean, yeah, a ton of data, and you see, it started generating something. It tells me, look, I don't have that information. I didn't get it. Can I maybe look into some other stuff? Maybe transfer to other companies, investment contribution, other capital expenditures. Maybe it's there, that information that you want, because it knows that there is some information available. And I actually say to the agent, maybe check the transfer to other companies. Let me again speed it up. So yeah, it checks for that. It starts running, thinking again which tool to use, and again it's querying. It failed for some reason, again, and then I hit the rated limit error because I used a ton of data. But this is just a small example. It's a failure, to be fair, but it's still something that an agent can do. This was just an example, to be fair. But with an agent built much better that can handle larger context window for models and filter the data much more efficiently, you can actually query the financial data in a much better way. This is another nice thing that I created. This is this is using both of these examples are using a project that I created called Orchestria, basically an orchestrator for agents. And in this case, I built an agent that has access to Git and can create text files, basically. So I tell it to create a to-do app, quite simple app, to be fair, in Vue.js. I give it access to a repository that I already created, and tell it to create the repository in a certain folder, everything locally. This is actually a bit scary because it's basically it can do things on my laptop, and I told it just do this stuff, and it started creating. I'll speed it up again because no one's want to see me write. And then I tell it to also commit the changes bit by bit. So since like a software engineer actually would do, and also since I'm not an expert in Vue.js, I ask to create a README with some instructions. And then it starts to do things. It clones the repository, status success. As I said, even a tool can do just a simple thing and do, yeah, it worked. Now it's creating something. This is actually quite strange because I'm not sure what was happening. Because it started doing this thing, it got stuck for a while, and then as you're gonna see, it's gonna return like that. I have no idea what happened, and I just said, I actually go check if something happened, because I was like, did it break? No, I actually created README, and there is something in there, and it just stopped. And I actually asked, as a person, did you finish? Oh, no, I didn't finish. And then it started doing things. It checked the status of the Git repository, commits the README, and starts doing things. Now it's creating the other files that are necessary to create the app. And now it's writing, trying to understand what to write in the app view file. There's an error. There's no source folder. It's gonna create the source folder, and then it starts writing again. And now it's gonna be successful actually. And you're gonna see the output of the tool that actually writes to the file in a second. There it is. It was successful. It's going to create. I actually have no idea why there's so much white space in between the messages, but it's still doing its thing. It created the to-do app view, to-do list view. It's creating everything. Again, I'll speed it up because no one wants to see just this. Okay, so it's creating the style CSS, the white space, just ignore it, and now creates the package JSON. Vite config, post CSS config for Tailwind config, and everything is successful. Finally, the index commits everything. That's the output of Git commit, and it tells me, okay, I'm done, cool. I go check the repository because I expected to see something and there's nothing. I was like, what's going on? And I just go, can you push, please? And yeah, it does because it can push too. It can push and pull and clone and do anything. It has access to Git. It pushes. Okay, sorry, I'm done. Refresh. There you go. You got the app. I just want to test it out. There are the instructions there. So I go in the app folder, run npm install. I mean, it's a node project after all. It installs things. It's fast. I promise. Okay, done. I run npm run dev. Cool. Started on localhost. Bam, it works. Yeah, I mean that's something that I've done 2 days ago. It took maybe a day to create the tools to actually make the agent be able to communicate with Git and create files. I already created the project that actually orchestrates the agent and handles the loop. It works. I'm just testing it out right now, and right when you talk for PugliaTechs, maybe do something else. But yeah, this is just something that you can do with agents. It's almost a person. And maybe it's better than some developers, who knows. Yeah, it works, it's kind of nice. I actually didn't expect this good enough quality. So, this is actually using Claude by Anthropic. It was Claude 3.5 Sonnet, the latest version. And it's one of the best models in my opinion. Didn't cost that much either. I think it was less than $1, less than €1, something like that. And so yeah, I want to go through some of the common frameworks that exist to create this kind of agents. I'm biased. I work on Haystack, so it's gonna be the first one. You can create graphs with Haystack, so you can basically create a whole message loop and that communicates with the model. Basically, kind of what I shown at the start. There's LangChain. It's actually not LangChain, but LangGraph that use it, and then you can use LangChain in LangGraph. But basically, kind of similar. Lets you create graphs in a kind of different way that I don't like, to be fair, but whatever. There's Llama Index. They actually have a really nice way to create graphs that actually implement agents, and it's called something like Llama Index workflows, something like that. I don't remember exactly, but it's there. Then there's the RAG flow. I heard quite a lot of this one. It's not just for RAG, but it can be used to create agents too. I never used it, to be fair. I tried there are so many tools like that I can't test them all. Then there's mine. I created this one. The examples that I shown earlier are actually built with this one. It's called Orchestra. Then there's Sci-Fi, or better, RAG to Riches. This is actually more to create RAG pipelines or RAG applications, but it can work for agents too. There's Langflow. This is actually really nice because it's a no-code tool. You can actually see the steps that the pipeline takes to actually create the agent. Anyone could do this even without using code. If you can code, that's certainly better, but that works too. And there's also QAI. This is really nice because it can do something. It's called Q for a reason. It can create multiple agents that can talk with each other. Something that I'm gonna talk in a while. And this one is really nice too. It's a bit more complex than the other ones, but the idea is the same. And it requires code, though. You need to be someone that writes code. And I want to talk about some of the patterns that exist to create agents. The fundamentals are really simple. It's just a loop. The user writes something, you send that to some model that can be OpenAI, Anthropic, Olama that's running locally, an NVIDIA NeMo server, whatever. You get something back that can be either some text that you can show to the user or a function call. If it's a function call, you call the function, pass the result to the model, and then go back, and then repeat the same thing all over again. And that's it. This is the way that you implement an agent in simple terms. And then you can add things in between these steps. One of the first could be planning. This is actually done more on the model side, but an agent can plan what to do and actually call multiple tools in sequence or even together. You can actually call them concurrently and then return all the results to the agent, and then it keeps doing its thing, or even sequentially. It depends on what you want to do. There's also the human in the loop, let's say. Something like an agent asks um, the, the app to do something, and you want to be sure that actually that thing has to be done. So you ask a human. The human says, no, don't do that. Then it goes back to the agent that does something. That depends on you. It can maybe do that only for certain tool calls. For example, I created some tools that can act on the local file system where their agent is running on. And it asks for confirmation from the user if you actually want to delete some files, because that could be dangerous. And then if the human says, yeah, cool, just call the tool, and then you send back again the output of the tool to the agent. That's long-term memory. This is something more interesting. Most agents, if you go on Anthropic or OpenAI or whatever, there's gonna be a kind of memory for the chat, at least, that's limited to the context window. So this is kind of like adding RAG in between. So basically, the agent can save the memory as it communicates with a person or other agents, and that's stored somewhere. When necessary, you can actually do some kind of RAG to retrieve that long-term memory that is solely related to the task at hand and get back some part of it or mm, um, more of that. It depends on what you really need to do. And this is useful because, if you have short context window, or you reach the limit of a context window, this can help a lot because you can store something that has been said earlier somewhere else. Then there's also multi-agents. This is something that I actually talked about earlier, that you can kind of create with QAI. And this is really interesting because these agents, I call them all agents, but it could be agents specialized on certain tasks at hand that can do something really better, but something else not that good. Or maybe they're limited in the set of tools that they can access. Because sometimes if you have too many tools available for an agent, the agent might be confused about which tool to pick. So this could be beneficial. So they actually kind of talk with each other and decide what to do. That's really something that I really like, and I want to experiment more with. For example, you can have for a tool of engineers, a team of engineers that are just agents, and something similar is the hierarchical agents. You have an agent that is just a manager, and then the agents communicate just directly just with the manager agent, and from there they execute this or that depending. If they're depending on what they're specialized. There's yeah. That's it really. If anyone has any question, I'm not sure how much time. And it's, yeah. I'm not sure if anyone has question live or on the slide or whatever. Oh, yeah, we have another one. You want to switch to? this one was on. I mean, it looks.
Okay, now?
It,
Yeah? Okay. No, I was saying in the presentation, obviously, it was a fantastic overview, but sometimes when people talk about agentic and agentic workflow, the black box is a little bit the tools. And the tools could be like an API. What's there? I think this is the most interesting piece that sometimes people like just stuck into the kind of general schema, but it's actually I think the action, the juice, because there is where you have the data, and it could be data or could be I don't know something else like Lambda, something else. So I'm just wondering, what's your take on that?
I mean, really, that's what you're saying. I mean, that's really a reality of it. A tool can be anything. On my project Orchestra, I implemented tools or CLI tools, for example, that can be Python script that can do anything. For the first example that I shown, it was just a script that was querying a PostgreDB and getting the information from there. On the second example, it was something that was executing Git commands locally. If you need, it could be a whole agent that just does things and then gives you something back. It can be anything. It's really a black box because it can be anything, and that's normal. That's a feature. That's not a bug, really.
Maybe if I can add some extra. But the second is really is a little bit of trial and error now. But I guess at some point we need some guardrails to make all, if you have millions of calls there and you just find trial and error instead of having the perfect query. How do you see this gonna play out?
Yeah, maybe I should have talked a bit about guardrail now that I think about it, but yeah, maybe you could. The fact is that it always depends on what the agent thinks it needs to call to complete the task at hand. If your tool is written in such a way that that does just one thing and one thing only, the tool is gonna recognize that it needs to call that tool. In fact, for the Git example, I didn't create a Git tool. I created a Git clone tool, a Git add tool, a Git pull tool, a Git push tool, and so the tool could understand that it had to call that tool and that tool only with the simple input, and it would return something as output. I think that's the best approach in my opinion. If you just have a tool that is Git, and then it's basically a command line that you can pass anything to it, the tool is gonna do that, and it's gonna treat it as a command line basically. It could also execute something else that is not just a call to Git, but maybe delete your files locally, and that can happen. It just depends on what the way that you build the tool. That's the best way to guard really, in my opinion.
Someone else?
Mike.
Curious about how they work internally. You were talking about guardrailing them, but how does it work? You prompt them, just use this tool, don't do anything else, don't write any command other than that. How do you tell a language model, which basically just returns text, to specifically and always run those commands, and how do you do that?
Okay.
My question is, why using language models instead of something else that is trained just to do that task?
That's an option. I mean, if you have a smaller model that just is trained to do that thing and that thing only, that's fine. If you know that you need to do that thing and that thing only, but it's limited. That's the problem. An LLM might have a broader scope and can do more things. In the example that I shown, it was just create a view app, but it could have done. Could be maybe create a backend app, create a much. It could have done much more given the tools that it had. But also about you asked about how it actually decides. Uh, it depends. I mean, I used Claude again, and that has a system prompt that is actually kind of, it's not that hidden, but it's always used, and Anthropic always add that when you make a call to the model, and that actually instructs the model to call the tools and or function or whatever only when necessary. You can actually provide your own system prompt if you want, and that can do something else. I actually created a system prompt for the model that I actually shown for the full stack engineer, and that was a really simple prompt saying, "You're a full stack engineer. You create code, and that's it." The other one was much more broader because I actually provide it was just to query data for financial data for 2024. So I provided all the the table names of all the financial data that contain financial data for 2024, and limited to that only. So it gave the way that you can use the system prompt for on your side is add more data that is always available to the model, and there's always going to be another system prompt that's being created um, by the model provider, and also depends the way that the model has been trained. For example, Llama 3.1, maybe Llama 3.2, actually has a certain specific way of calling tools or function calls. And if you actually try to let it make it generate a different format to call a tool, that's really hard to make it work because it's stuck to that thing, and it's not always gonna use that thing. But even with your system prompt, it's limited. So you need to adapt yourself to the model too. And right now, model provider, they actually return you a JSON response that says, look, this is the function call the tool with these inputs and call this tool. In the past, you couldn't do that easily. I mean, in the past, just a couple of years ago, it would return text. You could say, look, return JSON formatted like this and like that. And then you would pass that, and if it was correct, you would say, okay, I'm calling the tool, and then provide the output to the model. If it wasn't correct, you could say to the model, look, this is not correct, and you regenerate it. And that's actually how people started creating agents. And then it went from there because model provider actually created the...
So now the model provider returns you directly a function.
Yes.
So models are trained to do function
Yes.
calling. Okay.
There's probably also in the backend they do some kind of parsing of the generated answer and verify that it actually matches something, so it doesn't. They don't make you pay for something that is wrong already. So they may be regenerated already. I'm not sure about that. Maybe the models are that good. Who knows?
Just only one. Um, uh, I don't understand. When you call these agents, there is only a configuration to do it.
What do you mean?
You have to configure your orchestra
Mm-hmm.
to create an agent.
The way that I built the tool is basically you saw the all loop message user model and functions. That's already implemented, and I made it easy enough to create just a YAML file that can configure the agent with a list of tools that you can call. But if you want to create a tool, you still need to write some code. As of now, I only support Python because I've written the tool in Python, the project in Python. But I plan also to add, for example, support for Docker so that you can wrap any tool in a Docker container and call it whenever. But yeah, that's the way that it works as of now. I mean, but you could write your own code that actually has the whole loop and create and calls only the function that you already created in the code or whatever. I mean, basically, depends on what you need to do.
Okay. So Orchesia is evolving.
Uh, Given the time that I have,
And
maybe.
for every agent, you choose some configuration different because you want that model.
Yeah, yeah, yeah. Basically, that's it. When I actually can say orchestra create agent create, and then it asks for the name of the agent, the description that is actually not used that much right now. It's just facing. It asks for the model provider that is Anthropic or Olama. So now it supports that. The model, the system prompt. If there are extra generation arguments like the temperature of the model, stop words, whatever. Is that okay? And I was saying, yeah, and then it asks for the tools that it supports, system prompt, if there are secrets to call Tropic, this kind of stuff. And to create a tool is a bit different because you gotta write code. So, and the way that I've done it's really good because I'm pushing all the tools and the agents that I created on some repository, and you can download them and run them locally as much as you please. I mean, I still need to evolve it a bit and document it better, but there's potential, I guess. I mean, hopefully, who knows? We'll see. And any more? I think we're over time. I'm not sure. We're good. Thanks.
Thanks very much for your contribution. I think this is one of the most trending topics, really touching all industries, all businesses. So really, it's important for us to know what's happening already today and what's going to happen tomorrow or in a year. What's the perspective? So seeing what's being built in the community, what's being built in businesses, focusing on this really tells us what to focus on right now, today.